Hey guys, what's going on? This video is going to be a review of select problems from Standard 2.12.1 review sheet that I handed out on Monday of this week. So we just have several problems here. I think we have 2, 4, 5. We have 4 or 5 total problems here. So they're numbered on the sheet here. So let's take a look at them. Again, if you have questions on any of the other ones that I don't do here, let me know in the comments or something, and I can try and make a new one showing that. Okay, so in problem 2 here, our goal is to simply find dy dx. Again, with implicit differentiation here, our goal is we're going to go through and derive all the terms following any rules that apply. And anytime we do the derivative of a y, we multiply by dy dx. Okay, so I'm going to start with the derivative of 6x squared, which is simply 12x. The next term, this minus xy, is a product rule because we have a function minus x times a function y. Again, here's where we need to be careful. We've talked about this a lot, but anytime we see a product rule with that leading term being negative, even though product rule is plus in those derivatives, it's going to end up being minus. I like to think of my first term as negative x and my second term as y, just so I remember that negative on both. Okay, so the derivative of the first is negative 1 times the second is y. So I've got negative 1y, or I'll just call it negative y. Again, product rule is that's the derivative of the first times the second, plus the first, so it's plus negative x. Instead of writing plus negative x, plus a negative is subtraction. I'm just going to write minus x times the derivative of the second. The derivative of y is 1, but since I'm doing the derivative of y, I need dy dx. There we have it, the derivative of the first times the second plus the first times the derivative of the second. Now I just need to keep deriving. The derivative of negative 5y to the fourth would be minus 20y cubed dy dx equals 12x squared. So there we have it. So we got 12x minus y minus x dy dx minus 20y cubed dy dx equals 12x squared. Okay, now my goal is to isolate the dy dx's. Now both dy dx's are on the same side of the equal sign. I can keep them there and subtract the 12x to the other side and add the y. But I actually like, if I move both of my dy dx's and that 12x squared, then I feel like I can get more positives than negatives. So I'm going to go ahead and add x dy dx and add 20y cubed to the other side. And I'm going to subtract 12x squared. Now remember, when we're moving things across an equal sign, okay, their signs always end up changing, right? If something is negative, I add it over. If something is positive, I subtract it over. One of the mistakes I see people making from time to time, right, is they move something but don't change signs, okay? So I'm going to leave the 12x minus y. And I'm going to subtract this 12x squared over. And I'm going to add both of these to this side. Because they're both negative there, they're going to add over and both be positive over here. Okay, so I have dy dx alone and together on the right side of the equation. Now what I'm going to do is factor out dy dx from the right side. And over here I still have 12x minus y minus 12x squared. Then I'm going to go ahead and divide by x plus 20y cubed. I know that this answer can't be simplified because I see coefficients of 1 and -1, so that we can't, there's no common divisor for coefficients. Also, I see a lot of x's and y's, okay, but not every term has an x and not every term has a y, so that's as simplified as it can be. Just a note here, if you have an answer that's like mine, but literally every sign is different, for example, this, you got an answer like that for dy dx, right? That also is correct. As long as every sign is opposite from my answer, then it's still correct. It's just a different way of looking at it, right? It's like -3/4 versus 3/4. They're the same thing. Okay? Good, let's look at the next one. Okay, this one's going to be a little bit more tricky because of the sign of xy, okay? That's a chain rule because I have a function xy composed within a function sign. And there's also a product rule in there, okay? This was one that was a struggle for a lot of people when we were looking at it the first time. Okay, and there's a couple of key takeaways that I need you to understand very carefully here. Okay, so I'm going to start with the hardest part here, the derivative of sine of xy. I see it's a chain rule, so I see a function. The xy is the inside, sine is the outside. So I start this, we remember from our chain rule, we do the derivative of the outside with respect to the inside. So it starts cosine of xy. But then I need to multiply by the derivative of the inside. The derivative of the inside is a chain rule, or sorry, a product rule, because I have a first and second term. Okay. Now, because I have a product rule here, I'm going to end up with a binomial for my derivative of the inside. It's very, very important that that binomial ends up in parentheses. So I suggest opening a parentheses here. Now the derivative of the first, the derivative of x is 1. 1 times the second is y. Plus the first, x, times the derivative of the second. The derivative of y is 1, but that's where we need our dy dx. Okay. I see a lot of people right here just putting a dot and then y plus x dy dx. Okay. You're going to end up getting this thing wrong if you do that, if you don't put this in parentheses. Okay. The parentheses here are very, very important. So instead of using the times, using the dot, use a parentheses and see, oh, this is a binomial. It needs to be in parentheses. Okay, so there I have my entire chain rule completed. Derivative of the outside with respect to the inside times the derivative of the inside. Okay, the rest of the derivatives here are easy. The derivative of 5x is 5, so plus 5 equals 18x. Okay, now we have some choices here on how we want to get dy dx by itself. Okay, my preferred method here was to distribute that cosine of xy. So I'm going to distribute that in and multiply to both of these. And when I write this, please know that the y and from the y plus x dy dx, that y and the y in cosine of xy cannot combine. Okay, that xy is tied into that cosine function. Right, so to distinguish it, I always write my y's or x's out front. So instead of writing cosine xy times y, I'm going to write y times cosine xy. Right. Here I'm going to put this x out front. And I always keep the y dx at the back. Okay, now I got rid of that parentheses. Now I can just work on getting dy dx by itself. There's only one dy dx that came up within this problem. So I'm going to go ahead and subtract away the y cosine xy and leave it like this. I'm going to go ahead and divide by x cosine xy. There's my final answer. Again, taking a look in here, there's nothing that simplifies in that answer. Okay, let's take a look at the next one. I've got 5y squared over 2x cubed plus 4y cubed equals 6x squared. Okay, by looking at this, we can see that this is going to involve the quotient rule. Okay, it's also kind of a bear to simplify. So I want to show you my preferred method of doing it. Okay, it's not the only way that works, but it's a way that works best for me, and you can use this way or do it a different way as long as we get that correct answer. Simplify. Okay, so I'm going to start with the quotient rule here. So I need to start with the derivative at the top, which is 10y, and note that I need my dy dx, because I did the derivative at the top, or derivative of y. So that's the derivative of the top, and I need to multiply that by the bottom, so times 2x cubed minus the top, 5y squared, times the derivative of the bottom, which is 6x squared, all divided by that bottom function squared. Couple of things to note here. It's that entire 2x cubed that's being squared. So I always write it first as the quantity 2x cubed, that whole quantity being squared. Okay. The other thing I notice is I've got all kinds of coefficients strewn about in the numerator here. I'm going to want to tighten that up on the next part. Okay, but for right now, I'm going to leave it like that because I know it's correct. And I'm going to continue to derive the rest of the equation. So 4y cubed's derivative would be 12y squared dy dx. Equals 12x. Before I do anything else, right, I see a couple of dy dx's here, but I really want to start cleaning up this big quotient here. When I see 10 times y times dy dx times 2 times x cubed, I like to write my coefficients first. My coefficient there will be 20. Then I write my x's next, which will be x cubed. Then I write my y's. Then I write my dy dx. I always, by convention, go x before y. Okay? So it's just a little bit simpler looking at 20x cubed y dy dx rather than 10y dy dx 2x cubed. Doing the same thing to the second term in the numerator, I see 5 times 6 is going to be 30, so it's going to be minus 30. And then, again, I'm going to write my x's first, so it's going to be x squared y squared. Over, and I'm going to simplify that bottom. 2x cubed squared means 2x cubed times 2x cubed. That's going to be 4x to the 6th. Okay. Writing x's before y's helps me sometimes with my handwriting to make sure I know the difference between x and y. It also helps me quickly and efficiently check, for simplification later. All right, now when I got to this point, my first initial reaction was to multiply everything by 4x to the 6th. Okay, and that works. But before I did that, I noticed, wait, hold on, this quotient is actually going to be able to simplify quite a bit. Because I see 20, 30, and 4 are all divisible by 2. And I see that every term has an x squared. So what I did is I divided by 2x squared on every term. So here's what I got. The 20 is going to become a 10. The x cubed is going to become x to the 1st. The 30 is going to become a 15. This whole x squared is gone. The 4 is going to become a 2. X to the 6th is going to become x to the 4th. So what I have now is 10xy dy dx minus 15y squared over 2x to the fourth. Because we're doing these problems without a calculator, simplifying ahead of time is always often a good plan. Now I'm going to go through and multiply everything by 2x to the fourth. So when I distribute this, right, the 2x to the fourths are going to cancel here. I'm going to be left with 10xy dy dx minus 15y squared, right? That's why I did that. When I multiply 2x to the fourth over here, I'm going to get plus 24x to the fourth y squared dy dx equals 24x to the fifth. Okay. Now, I see two dy dx's. They're both on the same side of the equal sign, and they're both positive, so I'm going to leave them be. I'm going to add over the 15y squared, factor and divide. So as I added that 15y squared over because it was negative over here, so it's going to end up positive on the right. And then factoring and dividing, I'll do that in one step. Dy dx equals 24x to the fifth plus 15y squared over 10xy plus 24x to the fourth y squared. Taking a look here, I can't simplify any x's because the 15y squared doesn't have an x. I can't simplify any y's because 24x to the fifth doesn't have a y. 24, 15, 10, and 24, it looks like maybe something is a common divisor there, but there isn't. So that's as simplified as it can be. Okay, next problem. I want the equations of the tangent line at the point 1,5. Notice I bolded the word equation there. Right? For an equation, we need a point and a slope. I know my point is the point 1,5. For the slope of the tangent line, I'm going to have to plug 1,5 into my derivative, dy dx. So I'm going to have to go ahead and implicitly find dy dx here. So starting with 2x squared, its derivative is 4x. The next one is a product rule. So the derivative of the first is a 2 times the second y plus the first 2x times the derivative of y, which is 2y dx. Okay, so I followed my product rule, equals 0. Now I'm going to go ahead and solve for dy dx. So I'm going to subtract away 4x and subtract away 2y. And then divide by 2x. Now again, here's a point where when I look at this, I see that it can simplify, right? Now, if you don't see that and you plug in, you still should get the right answer. You'll just need to simplify your slope at the end. But anytime I'm working without a calculator, I like to simplify as much as possible. -4, -2, and 2, I'll divide by 2. I'm going to say dy dx equals -2x minus y over x. Just a little bit easier to handle. Okay, now I got to plug in the point 1,5. I'm plugging in the point 1,5 into this dy dx. Remember, 1 is going in for x, 5 is going in for y. So I've got negative 2 times 1 minus 5 over 1. Negative 2 times 1 is negative 2. Negative 2 minus 5 is negative 7. So I get negative 7 over 1, which is negative 7. And I can write my equation y minus 5 equals negative 7, parentheses, x minus 1. And there's my final answer. Okay. All right, last one. Here I'm asked to find the second derivative in terms of x and y, and then evaluate that second derivative at the point negative 1, 1. Okay, so to find the second derivative, we first have to find the first derivative. So this is going to start off the same way that all the other problems have. I'm going to start by doing the derivative of the 8x plus 16y dy dx equals 0. And now I just want to solve for dy dx. So I'm going to subtract away 8x and divide by 16y. Now, especially on second derivatives, okay, we have to simplify this if we want to make this thing manageable. The numbers are going to be really, really, really big if we don't simplify this, okay? So don't start doing the quotient rule here with negative 8x and 16y. The numbers are just going to get too big, and it's going to take you way too long. So I need to simplify right here. And I'm going to say dy dx equals, both of them divide by 8, so it's going to be negative x over 2y. I like to circle my dy dx, okay, because I know I'm going to have to plug in so I can get it in terms of x and y. Okay, next, I'm going to do the derivative of both sides again to get the second derivative. The derivative of dy dx is our second derivative, d squared y dx squared. But the derivative on this side is going to be a quotient rule. So I'm going to do the derivative of the top, which is negative 1, times the bottom, which is 2y. Negative 1 times 2y is negative 2y. Minus the top, which is negative x, times the derivative of the bottom, which is 2 dy dx. All divided by the bottom function in parentheses squared. Okay? Now I like to take a second to clean this up a little bit. I'm going to call this negative 2y plus 2x dy dx. Okay, I like to write coefficients in the front. This minus is going to be plus. All divided by 2y times 2y, which is 4y squared. Okay. Now, if you want to right now, right, we have to sub this in for dy dx. But again, I'm always looking to simplify. I can simplify right now by dividing both terms, all three terms by 2. So I'm going to do that one last step just to make my life as easy as I can. A little bit of work now saves a lot of bit of work later. So I'm going to call it negative y plus x dy dx over 2y squared. Okay? Now I'm going to substitute in for this dy dx. And again, I have it circled up here, so it's easy to find. Negative x over 2y. That's going to be subbed in for dy dx. So I've got negative y plus x times negative x over 2y. Okay, x times negative x over 2y. I'm just going to multiply the tops here and get negative x squared over 2y. And I like to take one more step here to avoid having a fraction within a fraction. Right? If you look at, this is the fraction I want to eliminate. So I'm going to multiply by 2y here to get rid of this. But I need to do that on the entire top and on the entire bottom. So distributing that, I get this. I've got negative 2y squared then from that first multiplication, minus x squared over 4y cubed. Okay, and nothing can be simplified there. So that's my final second derivative in terms of x and y. The last thing I need to do is evaluate that second derivative at the point, I think it was negative 1, 1, I want to say. Let me double check. Yep, negative 1, 1. So again, this is going in for x, this is going in for y. So it's going to be negative 2 times 1 squared minus negative 1 squared over 4 times 1 cubed. 1 squared is 1. 1 times negative 2 is negative 2. Negative 1 squared is 1. So I'm subtracting that 1. And I'm going to get negative 3/4. There's my final answer. All right, so use this to help you study for that one. I'll have another video coming out shortly that will be about PVA. That's it for this video. Study hard tonight. Let's pass this thing tomorrow. Talk to you guys later. 2 chains, bye.